I've got hold of a Fusion Splicer and a competent operator, and we're going to try and join the Samsung One Connect cables, and if we can join it, we'll see if it works.
So this is a cleaver. It's just cleaving the glass. It's just scoring it and cutting it off clean so that we can fusion splice it together. If you had a jagged end, it wouldn't melt very well. I suppose we could get a look at that on the microscope.
Inspecting the ends of the fibers after they're being cleaved, you can see clean cuts and then another one being held in there that has just been snapped. So we can see the difference between the clean cut and a piece of glass that's just broken off.
So we're just going to try to splice these together. This is a fusion splicer, so it has two electrodes just here. That has an arc running over them and it melts the glass at high temperature. These fibers get held by these, which can move in while it's arcing, and it has a couple of cameras under each here just for alignment. We'll show you what happens when we're doing that anyway. And I'll just put my hand right over everything while we're doing this, so you can't see anything about what I'm doing. Look and see if this turns out shit or not. See, that one's pretty gnarly on the end there. Let's see what it does. See, it's gross. It's going to be whingy about the alignment too. It's fine. Because it's quite a... You can see it's red, infrared there. Yeah. There we go. It's again not cleaved super well just there.
Is that possibly because the diameter is slightly different?
Just gonna keep whinging about this. Just do it anyway. Ooh. It's not gonna... It's just got like a lump in it.
Good, is it?
Good, apparently. Yeah, it didn't go so well either.
All 8 fibers are probably joined now. It complained about some of them, but we decided to try it anyway. That it's been taped to this card so we can move it near the TV and see what happens. We've connected up the TV and we'll test it and see if it works. We'll switch on the TV, switch on the One Connect and see what happens. Yeah, it might not be very heavy. It doesn't look like it works.
Nope.
Yeah, it doesn't look like it's going to work, unfortunately. Maybe the splicers weren't good enough. We know some of them didn't turn out very well. And it's also possible that fibers are not in the right order because we've only assumed that it goes 1-to-1. It's been a week since we tried to join the fibers. Some of the joins failed according to the splicing machine, but we ran out of time, so wanted to test it regardless, and found it didn't work. But we're not going to give up. I'm going to try joining it again, but first we've got to work out what direction the fibers need to be connected. I've taken the backs off now to have a look in there. We'll have a look at some photos. So I borrowed a much more fancy oscilloscope than what I have here, and we tried to measure from the One Connect end to the TV end. So down here there's a little ground loop, and I probed along the coupling capacitors, and then on the TV end I connected 3 probes, since it's a 4-input scope, so 3 probes to the ends, So it was the 4 main data channels that we were looking at, and I was trying to match those to the 3 on this end, and the 4th would obviously be the 4th one, but the oscilloscope wouldn't show anything. The TV was running fine, the picture was fine, what we could see of it was hanging over the edge of the bench, but no data. I suspect that this scope is not fast enough. It's 200 megahertz. I thought it was going to be a faster one than that, but also probably these probes aren't good enough either, and we really need those really expensive low voltage differential probes, which, yeah, I don't have access to any of those, unfortunately, but I've got some ideas regardless. There's a look in the back of the connectors. It's just various bypassing and power supply things, but I could see there where the signals went, because there's a couple that are hidden on the other side, there and there and there on that one. Marked which is TV end, otherwise we'll lose track of it. So I've made this diagram showing where I think the fibers go. So from the one connect box to the TV, we've got 4 main data lines here which go to this end, and I've given them numbers 1, 2, 3, 4, and then following the tracks we can see they come through capacitors 1, 2, 3, 4, and at the other end they go through coupling resistors 1, 2, 3, 4, and then we've got this other group of 4 fibers which I've called auxiliary. As far as I can tell, only 2 data lines are being used here, although if there's other things it's some sort of low speed data, but there's 2 main pairs there. There's the transmit from the one connect, which is this one here, which goes on the other side over to here, and then because the scope didn't work, we weren't able to work out which one of these is the transmit out. And then coupled through resistors, there's the receive side coming through there, through those capacitors and through the resistors. And then we've got the same thing over here, so transmitting from the TV goes on the other side of the board over, and it goes to transmit from the same pins there as on there, and then receiving by the TV through capacitors through to here, through resistors. We weren't able to confirm which of the pairs coming out of this chip is transmit or receive, and I also could not find any information about this chip, but you can see that the transmit and receive are the same at both ends of the cable, and looking at the die inside here up close, this looks exactly the same as the one at this end, whereas in this case that one there does not match that one there. There's differences that I could see when looking up close, which would make sense because this is all 4 are transmitters, all 4 are receivers over here where the main video data goes, but this side they look identical, which makes me think that the number 1 fiber there would have to go to the number 4 position on this end, and the number 1 from here would have to go to the number 4, and 2 to 3, 3 to 2. Otherwise it's not going to work. You're going to end up with a transmit and receive banging into each other. So we'd wired it 1 to 1 to start with on this card here. Didn't work. Next time we're going to try it with these 4 reversed and these 4 reversed. Because the oscilloscope couldn't see any data, we weren't able to confirm whether these are reversed as well, but we can make an assumption that if these are reversed, these must be reversed too, otherwise it's weird. We can't tell for sure, but we can try it anyway. And maybe if there's enough time and it still doesn't work, we can reverse this one back so it's 1 to 1 and leave this one reversed. We're pretty sure this has to be reversed. Depends how many hours do we want to spend on this. I'm going to put the back covers back onto these, and you can see there's an exposed area of gold plating there, and it's underneath the receiver and transmitters, and in the cover there were little thermal pads, so they are transferring heat out to the cover. It was soldered Again, like the other sides, we're first going to remove that solder, and then we can clip the housing back together and then put fresh solder. Use some solder wick, just remove the solder so that it can fit, the cover can fit back on flat without any bother. Hopefully not stressing anything too much in the process. That's fairly clean. I'm going to have to clean these up as well. Get rid of that horrible lead-free solder so we can put nice stuff on it. And these might be slightly bent because of difficulty of getting them off. Okay, let's slide them back in. I don't know if anything actually pushes it down onto that pad. Just good luck, I guess. There isn't anything in the top to press down. The top covers are just empty. Maybe it relies on that little plastic frame thing being a certain thickness which goes between the middle, but even that's barely flush with the top. It's a bit strange. So we've got the order right. I'd written TV on those. And the other one, we might as well suck the solder off the top pieces in case we need to put them back. I'm not going to put them back unless it all works. I don't want to get ahead of ourselves. Oh, I haven't turned on any lights today. That's why it's a bit dark. There you go. That's better. Too excited to get into it. Forgot the lights. And squeeze that down a bit so it's tight. I guess there isn't really any reason to keep these open. Ah, there is. We're going to check the watering again. That's one thing that needs to happen. So I put these dots. I already had the red dot and I added the blue dot and decided that that was the pin 1s, and then there's red and blue dots on here. We need to confirm them. This is going to get peeled off, cut, and then stripped back longer because we've got to redo all the connections, and it was really fiddly before. I mean, the first time we tried it, because they weren't quite, well, they were long enough but not enough to make the job easy, so we've got to strip them back a bit more and then re-transfer the marks back a bit so that we don't lose them in the cleaving and splicing process. Okay, we're going to check the order of the fibers. We start with the red ones I've laid out there. Got this red LED and we got the microscope there. So they're laid out in order. So the top one should be 1. And you can see a very small red dot there. So yeah, that's 1. Number 2. Yes, there's a very faint red dot on the second one down. 3. Again, yes, very small red dot there. And then 4. Yeah, so those look good. Okay, I'm going to move this over to the blue ones. There's number 1. Yeah, that's shining out a number 1 hole. Yeah, that's all good. So I'll just do the same with the other end. Okay, so we'll mark those, and then we're ready to try rejoining them. The first part is to strip off the buffer, which is a plastic coating around the glass fiber. Which is fused to it so it doesn't come off very easily. And after that they need to be cleaned. After stripping the buffer off and cleaning it, then cleave the end to make it square and clean. Cleave it off to the right length so it's ready to be fused. Using this little machine, which scores the glass and then knocks it to snap off the end. So it's now cut to length, and we'll need another clean before it gets spliced together, fused together. And the offcuts go into that little receptacle there so they can be disposed of safely. You don't really want random bits of fine glass floating about the place. You line up the edge of the buffer with that mark there, so it will get cut to the right length for splicing together. Okay, that's 4 done. 12 more to go. We're going to splice cables together. Splice fibers together? What are we doing?
Splicing fiber.
We're going to splice the fibers together. Isn't splicing cutting though?
No.
Okay, we're going to splice the fibers together. Line it up so that the end is in the area where the electrodes are. And then shut this little cover to hold it. And this time we're reversing the order of the groups of 4, because that's what we determined is most likely the way they should be joined. So this one we've got number 3 going to number 2. And when that's ready, shut the lid. And then press start. And if it's happy with it, it will do it. And you can see a small glow there from the arc, or the heat in the fibers. Said it was okay. It pulls them a bit to check that it is joined, and then you can remove them. And put them in this tray at the back to keep them safe.
And we both turned out furious. I don't think it makes any difference what you know.
Oh, so it does just a quick arc to burn off any dregs?
Must be.
That's what it did, because there was a little lump there and it went, and then it went away.
That one's 0.00.
I think they've all been like that, or
1.
0, 1. Yeah, we just fired off a little lump of it then.
It takes it for quite a long time.
Great. Okay, well let's test it. We've joined up the cable. One of them was reported to have a bit of loss, but we decided to try it anyway, because it's annoying having to cut that one short and splice it again. So that's hooked up there, and we've got it connected to the TV, and turn it on and see what happens. Nothing? Yeah, that's a bit disappointing. Maybe the one thing that no, the one that went bad was in the video part, not in the other signals. Yeah. Okay. Didn't work. That didn't work when we had both sets of 4 swapped over. I've now rejoined the one that I think transfers the video from the one connect box to the TV to 1 and left the other one reversed, because I'm very confident that needs to be reversed. Let's try it and see what happens. It seems to still not be happy about it. That's a shame. Maybe we're at the end and we'll... yeah. Does it know which end is not plugged in? Must do.
That's what it's saying there.
Let's plug it in and see what happens. Oh well. It looks like you can't join it very easily, or the combination of send and receive is more complicated than what we've tried so far. After another failed attempt at joining the cable, I came up with another method to determine the order of the fibers in these connectors, and that is, if you point a camera at these while they're running, you can see the infrared light as little purpley colored dots. So I opened up both ends of the good cable and connected it up to the TV and the One Connect, and then recorded a video of each end. And when the power is first applied, it is possible to see this side, the one with the blue dot or no dot originally, light up in an order, and on the TV it's in consecutive order, but on this side it's not. And by carefully looking at the recorded video, I was able to determine the order that these four need to go in. And I've written that down here. So from the One Connect to the TV, and looking this way with the dot as 1, and then this way with the dot down the other end, you can see it's double crossed. It's reversed, as well as 1 and 2, then 3 and 4 reversed. So you end up with this assignment, which is known for those 4. We're going to try joining it to this order, and then trying some options for the red ones. At the moment, I think it's currently wired as 1-to-1, so we'll fix the blue and leave the red as it is and test it. If that doesn't work, we'll put the red into the same order that we determined from this, which is quite possible that that's the correct one. And if that doesn't work, I've sort of organized getting hold of a much more high-end oscilloscope than the one we tried last time, a 1 gigahertz scope, and we may be able to use that to determine the correct order if we don't get it in these first few goes, because I'm not sure if I want to try every possible. I've come up with some other options here, but it's just so tedious to keep rejoining this fiber. If we don't get it from the 1-to-1 which it has now, or the order that matches the blue, then we'll try measuring it again. That's the plan anyway. So let's try rejoining the blues to this order. I've stabilized the red ones because we want to keep that safe for now. I've cut the blues and they're marked with a green dot there where we're going to strip back. I'm going to strip off the buffer first, which is the outside plastic, using this wire stripper like thing. It doesn't slide off because it's fused onto the glass. Well, with this type of fiber it is. Okay, so buffer is stripped off. Now we've got to clean the glass. Isopropyl alcohol on a cloth and wipe them very carefully till you get that squeak noise. Gotta be careful because otherwise it wipes off the core number markings that I put on there. I've added some more a bit down. Oh, now we lost which one we haven't done. Have to redo all of those, I think. Okay, so those should be cleaned. Should be adequately cleaned. Then we've got to cleave them, and once they're cleaved, you've got to keep them very tidy and not, well, you've got to stop them banging into stuff. Otherwise you fracture the nice cleaved tip or end. So normally you'd cleave, then join them or fuse them straight away. I'm not sure if we do that. The issue is that this stuff, it's not individual fibers, they're all joined together, and you've got to strip back enough of the overall installation to be able to get in there and do the cleaving and the splicing while the others are remaining safe and connected. I'll try and organize this. Alright, let's see what we can do here. We're going to go 1 to 3. So I've got to find one at this end. Is this one. Might give them another wipe in case they got dirty on the way. Then we cleave this, which is number 1 on this side. So that's good. Now we've got to mount that in here. Okay, so that's 1, and then we've got to find 3 on this end, which is this one, and cleave it. Okay. Now we put that in this side. It's very springy. Close down the little cover. So we're going 1 on the side, 3 on the side. Then we shut this. Oh, it's a bit messy on the end there. Let's see. Yeah, it seems to give a little pulse and cleans off any burrs. Great. Proof test done. Alright, so that's the first bit. Put that over the back. Next one, we got 2 to 4. And keep these fairly well untangled. It still looks like it's got buffer mess on it. Oh, that one's got a bit of crust on it. They also look a bit far apart. Alright, ready to go. Oh, that one's got a bit of a glow. Hopefully that's not an issue. Okay, still good. No loss. No estimated loss. Alright, that's it for blue. So the red ones are still connected 1 to 1. What we need to do is slide a cover over those and then stabilize it. And then we'll test it and then we'll decide what to do after that. Okay, the cable is connected up now. Let's turn it on and see what happens. I'll also record with my phone the startup sequence seen on the One Connect. Huh. Okay, there's sound, but no picture. That's interesting. It's got the HDMI connected up to the One Connect here. Probably means that the main data channel that sends the video is not connected correctly. Let's wire it as we just into the order that we just wired the blue one. Continuing with rejoining the red. I've already done a couple of them. This time it's 3 to 1. Now we could get the sleeve over it, get it secured, and then we can test it. Annoyingly, this is quite a short. It's much shorter. Attach it down to that. Okay, let's set up the TV and test it. We're ready to power up and see what happens. Backlight again, but still no picture. Yeah, so I guess there's another order required for the red ones. That's annoying because we're running out of fiber cable. We'll have to try again another day, I think. Previously we reconnected the blue 4 fibers to the correct orientation, and that got some of the things working on the TV but not the picture. We tested with 2 arrangements of the red 4 fibers, the way it was wired, which was 1-to-1, and making it the same as the blue ones, and neither of those provided video on the TV screen. It stayed blank. Now we're going to try a reversed, all 4 swapped over 1-to-4, 4-to-1, and I have a good feeling about that one, because when you look at the PCB layouts and the connector PCB layouts, which we can see here, the 4 red fibers there and there go up through the boards through their differential pairs up into the 1 connect, 1, 2, 3, 4, and up into the TV, 1, 2, 3, 4, and we can see there's an auxiliary channel in both cases, which I called it auxiliary. It's the other data which goes through the chip and onto the blue fibers, and in both cases there's 3 from the red together and then 1 by itself, and it's the same at the other end, and the one that's by itself is the opposite on each side. So it makes me wonder if this is like an HDMI signal where it has a clock and then the 3 data lines. Perhaps that is the clock, which goes from 1 at one end to 4 at the other, and the other 3 data lines are reversed as well. Well, that's what I think at the moment. Let's try rejoining the fibers to that order and see if it works. I've started preparing it. The red ones here, they're getting a bit short, and the blue ones remain quite long because we only renewed those a couple of times. But now this has been done, I think, 3 times already, and we're about to do it a 4th. If we had to do it anymore, I might try stripping back this outer insulation and then sliding it up and then pulling the red fibers out, and so it just leaves it as a sleeve on the blue ones. And if we do eventually get it to work properly, then we can cut it again, cut them all back to the same length, resplice them all nicely, and then it'll be tidy. But I'm not willing to break this unless it breaks by itself from rough handling, or if we actually get it working. So let's begin. And we'll test it. So we've got to find number 1, final clean, without breaking it. Then we cleave. And for the other end, we've got to find 4. Then cleave. This thing's getting really short. Careful to align that. See how this goes. Seems to be okay. So that was 1, 2, 4. 2 to 3 is next. That was getting really short. Oh no, I snapped it off. Well, that's not going to work, is it? I think it's too short to cleave that. Okay, we're going to have to start again then with that one. That really messes it up. Might leave that one till later. So let's instead do 3 to 2. Okay, I think we're done. Should perhaps just inspect these to make sure it definitely is the right order. Joins are in different places. Should have slid out that short one and sleeved it independently. Now we've got a real mess here. Yeah, we'll try and attach it to this, and then we'll test it. Alright, we've joined the cable together. Let's try it out. Whoa, look at that! Worked! That's a nice, good, exciting surprise. Just mute that because we don't really want that echo. Well, there you go. So it looks like you can, let's not look at that. So it looks like you can join the fiber cables if you spend enough time. Oh, that's my hand, okay. Yeah, so this TV's got a busted panel, as you can see down there. It's like there's a... Oh, okay. Yes, as you can see, it's smashed in the corner, and so you get these lines across the bottom and this corrupted bit and down the side there. So it's perfect for use with a computer because you can't see the taskbar and you can't see your start button. Awesome. But yes, it's because of the break in the corner, it means not all the lines are working properly, so you get a very dull color to the image on this side, but it's fine, normal over this side. Possibly a bit too much because it's been cranked up to try and get more color on this side. But there we go. Joined cable. Samsung One Connect cable. And bits of marks on my bench that looks like dirt on the screen. Good result eventually. It only took quite a few goes, but we got there in the end. Very exciting. After 3 weeks of fiddling around, trying to work out what order, trying to measure it, all the splicing. This is the 4th fiber splicing session that we've done, and yeah, we didn't need to borrow the fancy oscilloscope to measure it. We got it. So that means we can finish off this chart now. So the answer is it's not going to be that one. It's going to be that one. So you join the blue side in that order, which is crossed, cross all four, then cross the pairs, and then you join the red side in this, which is just cross. So I need to publish that as official information on how to repair your Samsung cable, which means according to this chart, it's just straight through. That was the wrong pin, but anyway, you get the idea. That's how you repair a Samsung One Connect cable. You identify which fiber goes to which end point for both ends by shining lights down the ends of the fibers and looking at where they pop out. And then once you've done that and identified them, you splice them together in this order. Reversed and double reversed, using the dots on the connectors as a guide, like what we saw here. The red dot that's there originally and the blue dots that I added. Excellent. Hopefully that will get edited down into something that's not too boring to watch. You probably don't want to watch 4 hours of tedious fiber stripping, cleaving and splicing. Now that the cable is joined and successfully working, I'm trying to work out what I need to do to protect it. It's not ideal that one of the cores snapped today, which means that that one there is shorter, which makes it a bit messy. We could leave it as it is and restrain all of this like that in some loops so that it can, like, so it can not snap. Or I could cut all this off, restrip it back, and then try and get a clean run of all 8 being joined at the same length without any failures, and then it'll be a bit easier to protect it because they can all take one path. Go around once into the joins and then out the other side, and then that can be sealed into a little box of some sort to protect the join. And I think like this with the different lengths, this one really long and this one at 2 lengths with this piece here, it's not ideal, but it's a hassle going through the process of refusing everything, restripping, recleaving, refusing. So I don't know, we'll see eventually, but as far as this video is concerned, I think it's done. We've achieved the goal. We've proven that it is possible to rejoin the Samsung One Connect cables. If you've got access to this, and if you've got the patience of identifying the fibers in the connectors. You need something to hold these fibers securely and a bit more permanently than this piece of cardboard that they are currently taped to. I drew up a little holder bracket thing to 3D print, and I then drew that up in AutoCAD. That was the initial thing. It was going to have a solid center with some mount holes there, and then that got developed a bit further with holes moved out to the corners and this empty bit in the middle because it didn't really need to be filled in there. And then in AutoCAD, this is the final bit, a channel through there where the fibers can wrap, this little part here where the sleeve with the joins can get secured, and then a lid part to click on, and it has a rise there that will go down the center with an interference type fit. These parts got 3D printed, base, tray thing and the lid, and here they are, straight off the printer, and they fit together really well, which the lid clips on nicely, which is pretty good for a first time print with a guessed measurement between for how much smaller this inner lip should be than this. I just made a guess. I just scaled that edge down by something like 0.995 to make that edge, and it fits nicely. You gotta be a bit careful when 3D printing because the inside curves will always end up a little bit smaller than you expected, depending on the calibration of your printer, because as it's extruding material around an inside corner, it gets pulled inwards. There's a lot of things going on there. So these need to be tidied up just a little bit because there are some raised bits there from the final infill layer. So I want to get that nice and smooth. Similarly on here, it's a little bit. It's also got stuck down to the masking tape really well. I think the bed wasn't leveled properly because I printed at the same time, and there's not quite so much fill on the bottom layer there, but this one is really good. I don't know if that last bit of recording got messed up. For some reason there were lots of frames dropped, but no obvious cause for that to be happening. I'm going to scrape off the protruding parts just with a sharp knife. A file might also be a good idea. Or a belt sander, if I had one. Similarly on this, but I need an edge, because it's 0.8mm thickness. It's very floppy, so I can't easily slice that without having it hanging over an edge of some sort. I'll sort that out and then we'll try putting the cable into it. Nice and smooth now. Let's try putting the cable in. Put the TV on because I want to know right away if the cable gets damaged while this is happening. Yeah, we lost about 1.5 meters. I don't know if it was exactly 5 meters to start with. It was supposed to be, but it's 3.5 meters now. So we've lost about 1.5 meters of the cable from all the experiments while trying to work out which way around the cores are wired. And if we concentrate to looking at it with a camera, or looking at the good cable with a camera, we could have saved a bit of that experimenting, because we would have been able to get the other side correct on the first try. Unfortunately there's tape over the top of tape here. It's not very clever. We have a problem. The solid part is too long. That's a shame. Means I didn't measure it properly. I did end up making this a little bit different to my measurements. Yeah, because the solid part that's protecting it ends in that gap there, which was supposed to be left free for the insulated parts of the cable. Is that a problem? It's not a problem at that end. I don't know, it's fit in okay. Now I've got some hot glue, which is currently making a mess all over the bench because I turned it on way too early. Seems to be all fit in nicely. Isn't that fluff tucked in there? So let's try applying some of this glue. Is this weird little... yeah, it sort of worked. Yeah, don't squeeze down hot glue with your fingers. I end up stretching some of the fibers. Okay, well, that's enough to get it settled. Oh no, the hot glue melts the PLA because it's printed with PLA, which is, yeah, low melting point. To push that down with something that's not my fingers, now I've burnt my finger. Okay, well, it looks really messy, but everything has sat in there. I guess I should put some glue down there and down here where the bits end to hold that and hold that fluff out of the way so that doesn't end up coming out. Well, the TV's still working, so that's good. Okay, let's see if this still fits on. So I think that's the thing. Done. Successfully joined a Samsung One Connect cable and protected it. And that means if you're running this along the top edge of your skirting or some similar place, you could put some screws through here and hold that to the wall so it doesn't get wrecked, or to any other thing that you're running this along neatly and mostly out of sight. Very good. Hopefully that helps other people with broken One Connect cables get theirs working again.